In section 1-5, we applied the rules for adding and subtracting integers to adding and subtracting other rational numbers. In section 1-7, we will apply the rules we learned for multiplying and dividing integers to multiplying and dividing other rational numbers, such as mixed numbers, fractions, and decimals. Under the key concept at the top, it says that the same rules for multiplying integers apply to multiplying all rational numbers. When multiplying two rational numbers, you need to remember two things. If the sign of the factors are the same, the product is going to be positive. If the signs of the factors are different, the product is going to be negative. And you're seeing this a couple times now, but the tic-tac-toe board is helpful until you have memorized these rules. So when you have opposite signs, you get a negative. Opposite signs, you get a negative. And when you have the same sign, like two negatives multiplied together, you will get a positive. Or two positives multiplied together give you a positive. Under the Do You Understand section, I'm going to change just slightly what we've been doing. I am going to provide you with the answers, but things will either be blanked out where you would fill in a correct answer. You might have a choice of two where you're circling. There might be matching and things like that, just to get you a little bit more engaged. Okay, so number one, the essential question reads, how is multiplying rational numbers like multiplying integers? So take a moment, write that information down, and also think about what words are missing and fill those in. Okay, if the rational numbers have different signs, the product is going to be what? What word's missing, positive or negative? The product is going to be negative. And again, you could look to the tic-tac-toe board, which is easy to draw, if you haven't memorized those rules. If the rational numbers have the same sign, the product is going to be positive. Okay, number two. How do you multiply a decimal greater than 0 and a fraction that's less than 0? Okay, first of all, any number greater than 0 will be positive, and any fraction less than 0 will be a negative fraction. So we're going to have a positive and a negative, and we're multiplying. Take a moment, please write this down. Think about what this is saying and decide if this word on this line should be the same or different. You can circle the correct answer, and then you would fill in either the word positive or negative on that missing line. Okay, so you're going to write the numbers in the same form. So we have a decimal, we have a fraction. We want them to both be decimals before multiplying, or we want them both to be fractions. Since the signs are different, we have a positive and a negative. The product is going to be negative. Number 3, modeling with math. How does this number line represent multiplication of a negative number by a positive number? Explain. So in this example, we see we're starting at 0 and we're moving to the left, -3, another -3, and a third -3, plus this -1/3. Okay, so this number line shows that the negative number, the -2/3, is multiplied how many times? So you can see 1, 2, 3 full times, and then this 1/3. Now, 1 is half of 2, so -1/3 is half of -2/3. So this is multiplied. And so we're talking about how many times would be on the positive. So that would be 3, my paper keeps moving, 3.5. And the product, as you can see, we end at this spot here. It is negative. And that location on the number line would be -2 and 1/3. Okay, moving on to the practice problems. Number 4 says to use the number line to find the product 3 times -1.5. I'm going to just demonstrate how to start, and then you will complete the rest of the problem. So we always start at this neutral 0, which is our starting location, and we're going to move in the direction in the negative direction. 1.5 is our value. So it would be in between the -1 and the -2. And that's one time. We moved one time with a value of -1.5. So we have 2 more to go. So go ahead and fill in 2 more of those -1.5s. A second -1.5 would pick up here. And if we move a value of -1.5, we are now at -3. But that's only 2 times. We have to go 1 more time in the negative direction, a value of 1.5. So that would bring us in between the 4 and the 5. And our value is right in between the -4 and the -5. So we have -4.5. Okay, number 5. Which of these products is positive? Select all that apply. So there can be more than one answer. Go ahead and check off any of those boxes that show a negative product. In order for the product to be positive, we need to multiply two factors that have the same sign. In the first example, we have different signs, so this will be negative. Second example, I'm multiplying two negatives. That will give a positive product. The third example is multiplying different signs, so that will be negative. The fourth one has this factor 0, and anytime you multiply by 0, the product is 0, and 0 is neutral, so there is no sign for 0. And then the last problem here, we are multiplying two negatives, which will give you a positive product. So there are two correct answers for number 5. Okay, question number 6. There are 4 examples and not much space provided. So let's go ahead and organize our space. So we'll do question A here, B, C, and D in those locations. I'm going to go through 2 with you, and then I'll have you try 2 on your own. Okay, so letter A, we are multiplying 2 decimals. They're both the same length, okay, which means that they have the same number of digits. So we can just kind of stack them easily. If one of these was longer with more digits, that number would have to go on the top. Now we're going to just use the absolute values because if you have too many negative signs floating around in your work, it can get very confusing. So we're going to use 3.1 times 2.9. And then when we're finished, we'll have to go back and think about, based on the original problem, if our product will be positive or negative. Okay, so without a calculator, we're going to go ahead and distribute that 9. So 9 times 1 is 9. And then 9 times 3 is 27. I'm going to move on and distribute the 2, but I did move over to the tens here. So that's where my first number is going to go. So I'm going to use a 0 here in the ones place just to hold the place value. So 2 times 1 is 2, and 2 times 3 is 6. And then you're going to add those 2 rows together. Okay, I get 899, but clearly a number that's close to 3 times another number that's close to 3 would give you a number close to 9. And, so something's missing here. Don't forget to put back your decimal. Go back to the original factors, count how many digits are on the right-hand side of your decimal. There's 1, 2. So when you finalize your answer, put your decimal in the location where you would have 2 digits behind the decimal. Now I get 8 and 99 hundredths as a final answer. I'm going to look back to the original problem, and I can see that, in fact, this would stay positive because I am multiplying 2 negative factors. Okay, letter B, I have a mixed number and I'm multiplying it by a fraction. Now, when you're multiplying with fractions, you're multiplying across the numbers at the top and then the numbers across the bottom. But there's this number in the front that, I've got to deal with because that's not on the top or the bottom. So what I'm going to do is kind of I'm going to change this to an improper fraction using the circle method. Okay, so the circle method is really like a half circle here. It starts at the bottom, the 2, and it works its way around. I have the arrow here because whatever I get as I'm working with these numbers, I'm going to leave that number at the top, okay, when setting up my new fraction. So you go 2 times the 1, and then you add the 1. So 2 times 1 is 2, plus 1 is 3. So I get 3 over 2. The denominator stays the same. And then I'm going to multiply that by the negative 5/3. Okay, now the next step, we understand that we're just multiplying across our numerators and then multiplying across our denominators. But oftentimes when you do that, you have to simplify. And a lot of times you're working with some really big numbers, which can get you messed up. So if you can cross simplify before moving to the next step, it's really, really helpful. Okay, so cross simplify, they call it cross simplifying because think about railroad crossing and the symbol that you have on railroad crossing signs, it's an X. Anything that's on the same diagonal, any of the numbers are on the same diagonal, can be simplified if they have a common factor. Okay, so if I look at the red diagonal, I have a 2 and I have a 5. Now I can divide 2 by 2, but I can't divide 5 by 2. And I can divide 5 by 5, but I can't divide 2 by 5. So this is already simplified on that red diagonal. When I look at the blue diagonal, I have the 2 3s. And since I can divide 3 by 3 and get 1, I can divide this other 3 by 3 to also get 1. Now there's a lot of markings here, so I'm going to clean this up. I'm left with a 1 in my numerator and a 2 in the denominator for that first fraction, so that's 1/2. And in the second fraction, I have a negative 5, and then I have this 1 at the bottom. Okay, so now what we're going to do, we don't have any numbers in the front, we just have 2 numbers in our numerator and 2 numbers in the denominators. Now we can just go ahead and multiply across the top and the bottom. So 1 times 5 is 5, and 2 times 1 is 2. And since it's a positive times a negative, I have to remember to put the negative back. Now we can simplify that to negative 2 and 1/2 if we like. And both of those are correct answers. Go ahead and complete letters C and D on your own. Okay. If you need a few more moments, please go ahead and pause the video. It is best to engage, to try the problems on your own rather than just being told what to do, because you're not going to learn the math that way. For letter C, since this is a decimal and working with fractions is definitely a lot of work, I'm going to choose to turn this negative 3.5 to a negative 3.5. And now I can multiply the absolute values, 3.5 times 0.5. Notice I'm ignoring the signs for now because they just kind of get in the way. I'm going to go ahead and distribute out the 5. Carry the 2 here in the 25. 5 times 3 is 15, plus 2 is 17. I don't need to distribute out the 0. So I have 175, and 3.5 times a half is not 175. I have to remember to put back the decimal. There are 2 digits in my factors that are behind the decimals. So in my final answer, I'm going to put the decimal so that there are 2 digits behind the decimal. I'm going to also go back to the original problem to see that I was multiplying a negative times a positive, so the product will be negative. So my final answer is negative 1 7/75. If you chose to make the 0.5 1/2, use the circle method to convert that negative 3.5 to, let's see, that would be negative 7/2, and then multiply across the numerator and denominator, you would have got negative 1 3/4. So those are the same. Okay, letter D. I'm just going to rewrite this over here so that there's more room. Negative 4/5 times a negative 1/8. Now this gets very complicated because of the 2 signs. So mathematicians will often use the parenthesis to help separate those signs. Before you multiply across the numerator and the denominator, you're going to see if you can cross simplify. It's easier to do it in this step than all the way at the end. So on my red diagonal, I can divide 5 by 5, but I cannot divide 1 by 5, and it doesn't really work the other way either. But however, on this blue diagonal, I have a 4 and I have an 8. And I can divide 4 by 4 to get 1. And if I divide 8 by that same 4, I get a 2. Lots of lines here, a lot going on. I'm just going to rewrite to clean up the problem. So this number here becomes negative 1/5 times, and then this number, I have the 1 on the top and the 2 on the bottom. So I have negative 1/2. And then all you do is multiply across the top. 1 times 1 is 1. And I multiply across the bottom. 5 times 2 is 10. And then just make sure you go back and double check what the sign should be. So in the original problem, I had a negative times a negative. So my product will be positive. Okay, we are finished with the 1-7 notes on multiplying rational numbers.